So I'm quickly going to go through our company background, so I'll provide some information just to give you some context around what we do and why this matters to us. And then I'll show you our product just a little bit to give you some context and talk about some projects that we're involved in where we have an opportunity to begin to take this kind of technology out to the field, to aviation and to UAS operations. And then I'm going to talk specifically about a recent integration that we've done as part of the NASA ULI WinMap project, particularly with big thanks to INCAR and James for providing some very interesting live data that acts as a prototype for how you would use some of the types of things he was just talking about in an operational environment to provide additional aviation safety. And then finally, I'll talk very briefly about additional opportunities and ways that we might be able to partner in projects with you. So to provide a little bit of background about our company, we focus on detect and avoid. We're the leading provider of multi-sensor detect and avoid systems. We have offices in Oklahoma and North Dakota. We work all across the United States, including in Alaska and other places. And we're really focused on this for UAS primarily, but obviously much of what we do carries over into both general and commercial aviation safety and military aviation safety. We use a couple of NASA patents that we license as a core for our technology. We're a software company. We don't develop the hardware. We integrate with several partners who provide off-the-shelf hardware, and we're a premier implementer and user of some of the leading sensors for aviation safety in the US. We're really focused on providing a real-time picture of the airspace in terms of traffic and now increasingly weather and weather hazards, as you'll see as I show you some pictures here. We're really focused on allowing beyond visual line of sight flight of drones. That is a key goal for the whole industry right now. It's critical to a lot of the industry things that we've talked about and the economic impact. I served on the FAA's Beyond Visual Line of Sight Aviation Rulemaking Committee a couple of years ago, and we do hope that the first draft of those rules are going to come out very soon, which will have a big impact, we think, on the growth of the industry and including in both urban and suburban flying for drones. So for WinMap particularly, some of our goals we're really focused on bringing in weather and weather hazard data into an actual airspace management system. So we have multiple products, which I'll talk about. But airspace management is a core function, and then detect and avoid, mostly of other aircraft, but increasingly of wind and weather hazards. And so bringing that data in and being able to demonstrate how it can be used was our chief goal in being involved in this. And bring in real-time data. That's really critical because these systems are used at the ground control station while you're flying. And as you'll see later on, making the entire system ownership aware so it knows where your aircraft is in real time relative to air traffic and weather hazard. So we have 4 products. I'm really only going to talk about Flight Horizon Tempo. We have onboard products for doing collision avoidance and detect and avoid, but the product we're going to focus on is Flight Horizon Tempo, which is our fully online product, software as a service. So we have people, including drone ports, corridors, small airports that subscribe to that product and use it to be able to monitor drones and other aircraft in their airspace. The system can be used either on board for detect and avoid or on the ground with multiple variety of sensors. These are some pictures on the left here of us working. We've done multiple projects with OSU with support from OCAST here in Oklahoma to do radar integration into our system. We've also done work with NASA and the Air Force, particularly NASA Armstrong in California, and Ricardo Ortega, who's the originator of our patents. So the Tempo system, I'll just spend a moment on this. The software runs usually in the cloud, and it's going to pull in information from your autopilot or your ground control station, so it knows where your drone or UAS or advanced air mobility air taxi is located. It's then going to pull information in from transponders, and then it'll pull information in from radars, and then it's going to pull in online information. And so that's where the weather data gets really interesting, because we can rapidly pull in and use real-time integrated weather data to inform your overall picture. This is a really quick video I'm going to play for you to show you kind of how how the system works. This is an encounter. The white aircraft in kind of the center left there is flying through an encounter. Another aircraft is detected over there on the left-hand side. The software provides a warning on that, says you need to turn left and speed up immediately, and then it counts you through that. This is an ACAS-X compliant, what's called a resolution advisory. So that's a primary function of our software. So in addition to air traffic, obviously, we're trying to bring weather into this, which you'll see a little later. Then once you've gone through the encounter, you've kept your distance from the other aircraft, you can go back on your way. All right, so real quickly, some recent projects. We are deploying our system at drone ports for airspace management. We are developing a version for the Air Force Research Lab right now for a new drone that they're working on. We have a multi-radar and multi-node system for distributed use and distributed air traffic surveillance. And then we have a new portable mobile air traffic surveillance radar pictured there, doing some testing at the OSU Aircraft Flight Station. We've recently begun to add remote ID integration and some other things that we're going to be rolling out through the end of the year. We do provide this system to Skyway 36, which is the drone port here in Tulsa. And we have a variety of other airports and drone ports that we're going to be announcing through the end of the year that are using this system for airspace surveillance and air traffic management for drones at their facilities. All right, now I'm going to talk a little bit about the Titan NSF in-car nowcast integration that we've done. Big thanks to James again for providing this data and actually running the server that's providing this real-time data. So this is using something called Titan. This is an in-car and other contributors developed this to do tracking of actual storm cells, to isolate that algorithmically, and then do a forecast of where those storm cells are going to be over time. And so that is the data that we have integrated into our system in real time, and I'll talk about some of the details of that. It is with the idea that you would use this data to do pre-planning and to do real-time mitigation and avoidance of wind hazards and other types of storm hazards as they are occurring or immediately before your drone flight or your AAM flight. So that's the purpose of this. So as you see this, you'll see kind of how that fits together. The goal for us is obviously to improve flight safety, improve safety initially for drones and then for advanced air mobility aircraft and eventually for all aircraft, where this becomes data that's just routinely used. And so by piloting this project, that's really what our goal is overall. Okay, so this is another video. I'll go through real quickly here that provides a picture. So what we've done here is we had some nice storms yesterday. I took this video yesterday in which we're using this Titan system. It is tracking and creating these storm volumes of variable intensity. So it knows the intensity it wants to track, and then it is predicting over a 30-minute, 60-minute, 90-minute, and 120-minute period where that storm is going to be. So we're really lucky we had these storms yesterday that we could use in the system to demonstrate this. And as you turn those on, you can see immediately in 3D within the context of your airspace, and potentially while you're flying, where the storm is predicted to be over the next several minutes and the changing contours of that storm. So we have this as discrete layers. We can really layer it or display it any way that is convenient for a particular type of operation. But this is this system actually being used with real-time data in our software for airspace management yesterday. So this is just a little information. I'm not an expert on this data or the data source or the modeling, and James conveniently can answer all of those questions. But this was just something that we learned about as we were doing this implementation, about how the system isolates these storm cells, decides what it needs to track, and then begins to track and predict those. And so it's using that radar data to do that, and then we put that into Flight Horizon in real time. This is interesting. This is an overlay of the Titan data with National Weather Service radar data, so you can see how it's identifying and isolating and then providing those predictions forward through the evolution of the storm. So you can see that in real time and then over those time intervals as you are preparing to do your flight. Here's another picture that I thought was really interesting because it shows the evolution and change in intensity that's predicted for that storm. So you can see where the areas are in which you may have hazards, and then as those hazards change over time. And then this is that same set of storms from Louisiana yesterday, just to provide a little more detail on how we've divided those layers up. We can actually put them all in a single layer. We can do other types of predictive work. I'm going to show you another picture here in a second about actually what it would look like to fly through these sorts of layers. But we have a lot of other airspace data that we can provide on top of this. So this is a picture of our system running a simulated drone through one of these hazard areas, and the storm is actually coming towards the drone. You can see here, and I'll provide a little bit of a zoom in here. We have a safety buffer that kind of yellow hockey puck is a well-cleared distance for avoiding other aircraft, and that follows your own ship, your own aircraft around, and then we have a forward trajectory for your aircraft that's predicting where it's going to be, which helps you to figure out what types of hazards, either air traffic or weather, that you might be about to encounter. And then of course you have this volume of this predicted storm in front of you that you can see in real time where the storm is going to be. Now obviously that's the 100-minute front that's coming towards you right there, so you may be able to get away from it long before it gets to you. But you do have an idea of where the storm is with this sort of 3D picture and these volumes in your airspace. And this is really typically how our system is used, to be able to track where that drone is, where it's going to be, or your air taxi. So just a few details about the integration. So we're pulling this in, it's being provided to us in 6-minute intervals, so the prediction is being remade every 6 minutes, and then we're providing those 30, 60, 90, and 120 layers, so you can see those volumes evolving. It provides that precise storm core location, and it is designed to be color-coded, so you can very quickly, as a pilot, determine where your hazards might be. Next steps, potentially for us in this project, would be to provide real-time alerts. So we have real-time alerts now that are providing industry technical standard compliant collision avoidance for drones. We would then layer on top of that, and we're very excited to do this, those wind hazard and weather hazard alerts, which will look a little different, they'll perform a little bit differently, but with the data that we have now in the process and the airspace management system as it exists, we're primed to be able to do that very easily with this data source and other similar sorts of data sources. If you have a particular aircraft, almost everything in our software is configurable. And so if you have a larger aircraft that's certified for certain types of weather and not other types of weather, we can adjust the systems and we can expose that to the end user. So when you create an aircraft in our system, you actually characterize the performance of that aircraft, and that allows our system performance calculations in the context of your particular operation and your aircraft. So that's the next thing we would do with that. And then obviously being able to include things like fast eddy and very discrete urban forecasts and predictions, and the ability to plan around an urban environment and then have real-time data about that urban environment as that data is collected and then inserted into your airspace management system can provide a very high level of safety and value for our AAM end users. I'll just mention we have a lot of other data that we already include. We include a variety of radar sources, wind observations, NOTAMs, all this sort of standard stuff is already built into the system, in addition to airspaces. So you can figure out where your airports and facilities are located. Here's the Dallas Fort Worth Airport with its airspaces represented in 3D with the weather going on around that. So you can see that in real time. All right, I'll wrap up here by emphasizing, as Jamie talked about, UTM. Uncrewed traffic management is a way to take systems like ours and begin to pull in information about where other people are flying, share information across multiple nodes and servers. It's essentially a set of protocols and standards that NASA developed to begin to create uncrewed traffic management across the United States. Our system is UTM compliant, so we can talk to other people's servers, And we can pull all this information in and share it. So if you're using a ground control station that is UTM compliant, or you want to use our system as a ground control station to be able to pull in information about where other people are flying and what other observations and data might be available in the UTM system, we're going to be able to pull that in. So that's really exciting, and it's kind of universalizing access to the types of data and capabilities that we're using. UTM is really the first time that this sort of distributed, almost cell phone network style of data distribution has occurred in airspace management. That's why NASA is so excited about it and why the industry is trying to adopt it, is it provides this flexibility to have multiple federated data sources that are feeding a common set of shared services and shared applications that everyone can use for flight safety. So that's really exciting for the industry. As I said earlier, we are rolling our system out to a variety of drone ports and other types of operators and operations, including some for the military. We've done work for the FAA, and then we're increasingly working for public-private partnerships where there are essentially drone airports being developed, which is a great development. And we're working on some of those now. The picture here on the right on the bottom is NASA using one of our systems for their supersonic flight research. On the left-hand side are some of the first flights that we took with Skyway 36, rolling our system out at the Northern Plains UAS test site on the lower left there. So upcoming opportunities, fleet operators, partnerships, we're very eager to partner with anyone who is flying drones regularly and has a need for this type of system. Obviously, if you have a data source that you think would be valuable and could eventually provide safety and commercial value to the industry, that's what we exist for, is to take that out of the lab and bring it to the end user operator. We also have been successful with SIVRs, and so if there are opportunities that you think could be proposed, we'd love to talk about that, and any form of data that you think would be useful to the industry. This is a picture of us testing our new DTEC 7360. This is a large mobile radar that we are using here in Oklahoma. This is the first one in the U.S. It's probably the most advanced 3D radar available right now. It's the only one that's being used for airspace management. We have it at our office in Oklahoma City, and we're using it, planning to use it all over the country. So we're really excited about that and the support that we've had in obtaining that and making it available for piloting these types of projects. So that's my presentation. I'm happy to take a few questions if we have time.